Hello, and in this video we're going to talk about two concepts known as sample spaces and event spaces. And this will lay the foundations of probability theory, which will be in the upcoming video. Alright, so let us assume we have an experiment. Suppose you have an experiment. Then, the sample space and I'm going to abbreviate it as S, is the set of all possible outcomes for that experiment. And the event space, and I'm going to call it E. Let's write it in another way. E is the set of all events of interest. So let us do an example. Suppose we flip, say, 3 coins, each of which can obtain either heads or tails. So what is the sample space? So the sample space is going to be the collection of all possible outcomes. So you could either get heads, 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 tails, heads, tails, heads, heads, tails, tails. You get tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. So we also could have got that the size of the set by the fundamental counting principle is going to be equal to, well, we have 2 possible outcomes for the first, 2 possible outcomes for the second, and 2 possible outcomes for the third. And these coins are independent of one another, so we just simply multiply these events together, and that's going to be 2 cubed, which is equal to 8 possible events in this sample space. So, suppose we are interested in obtaining at least 2 heads. That is, the event space is the set of all events such that we have at least 2 heads. So at least 2 heads means we could have, say, heads, heads, tails, heads, tails, heads, tails, heads, heads. Let's see. And we could also have more than 2 heads, right? Because it says at least. So that could be heads, heads, heads. So if that is the case, then that means the size of the event space is going to be equal to 4. So that's going to be a possible event space and the sample space if we flip 3 coins. Alright, so let us take another example. Suppose we flip or roll 2 6-sided dice. So 2 6-sided dice, so that means we have die 1 and die 2, each of which has, 6 sides each. So what is my set of all possible outcomes? So that is, what is my sample space? So I could get 1 on the first and 1 on the second, or I could get 1 on the second and 2 on the second. I could get 1 and 3. I could get 1 and 4. I could get 1 and 5, or I could get 1 and 6. Or I could get 2 on the first and 1 on the second, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. And I can continue this process onwards until I get 6 on the first, 6 on the second, 6 on the third, 6 on the fourth, 6 on the fifth, and 6 on the sixth. So these are all the possible outcomes that you could get. So that means, well, how big is the sample space? So we have 6 possible outcomes on the first and 6 possible outcomes on the second, and these dice are independent. So that's going to be 6 squared, which is going to be 36. And suppose we are interested in obtaining a sum of 5 or less. So a sum of 5 or less. So how can we get a sum of 5 or less? So we could get, so let's start with 5. So how can we get a sum of 5? So that can be 1 and 4. That can be 2 and 3. It could be 3 and 2, or it could be 4 and 1. And please note that these two events are different because they come on 2 different dice. So that's the sum of 5. Now let's focus on the or less part. So how can we get a sum of 4? So the sum of 4 is going to be 1 and 3, 2 and 2, 3 and 1. How can we get a sum of, so next is going to be 3. So that's going to be 1 and 2, 2 and 1. And then how can we get a sum of 2? Well, that's just going to be 1 and 1. And it's impossible to get a sum of 1, 0, or negative values. So therefore, this is all the possible events that we have here. So if that is the case, then that means the size of our event space is going to be 4 plus 3 plus 2 plus 1. And that's going to be, let's see, 7, 8, 9, and that's going to be 10. So that is how to construct the sample space and an event space of a desired experiment, and also a couple, ways of counting the size of these things. Let's do one more example that's a little bit more involved. So suppose we flip 7 coins, which could result in either a heads or a tails, of course. So a little bit more bigger, so it's just a tad bit more, it's not different from the first example, but it's maybe a little bit more involved. And we are interested in obtaining 4 heads. Alright, so I'm not going to list out the sample space or event space, but I'm going to sort of calculate them without it. So the size of the sample space, so how many coins do we have? Well, we have 7. So there's 2 possible outcomes for the first, 2 possible outcomes for the second, 2 possible outcomes for the third, all the way down to 2 possible outcomes for the 7th. So that means this is going to be equal to 2 to the 7th. And let's see, what does that come out to? So 2 times 2, 3, 4, 5, 6, 7. So that's going to come out to 128 possible outcomes that you could have for that. Now the event space, E, is the set of all events such that we have 4 heads. So 4 heads. So let's try and list them. Of course, it's impossible in practice if this number is large, but we could have heads, 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 tails, tails, tails. So that's one possible event, right? We could also get 1, 2, 3 tails, 4 tails, tails. 1, 2, 3, 4, 5, 6, 7. So those are 2 possible events, and there are several more. So my question to you is this: are these events equal? with respect to what we care about? The answer is yes, they are both what we care about because they're both in this event space. So I'm going to ask this question. Does order of H matter? The answer, of course, is no. So how can we count things such as this? Well, recall this is what we call a combination. So a combination is the set of all reorderings of a group if the order does not matter. So that means what? That means the size of E is going to be equal to, well, there's 7, and how many heads do we want? Well, we want 4 of them. So this is going to be equal to 7 factorial over 4 factorial divided by 7 minus 4, the quantity factorial. So this is going to be equal to 7 times 6 times 5 times factorial divided by 4 factorial times, well, 7 minus 4 is going to be 3, times 2 to 1. So my 4 factorials will cancel, and my 3 times 2 will cancel with the 6. So we're just going to be left with 7 times 5, which is going to have different possible outcomes out of our total. How many did we have total? 128. So we have 128 possible events in this experiment. Only 35 of those events will be ones of interest. And this is the difference between a sample space and an event space, and a couple strategies of how to calculate the size of them.